Hello everybody, today we're going to test a claim about a standard deviation. So let's go ahead and work on this problem. So we have a table here that contains waiting times of customers at a bank where customers enter a single waiting line that feeds 3 teller windows. Test the claim that the standard deviation of waiting times is less than 1.2 minutes. Which is the standard deviation of waiting times at the bank when separate lines are used at each teller window. Use a significance level of 0.01. Assume that the sample is simple random sample selected from a normally distributed population. So we have the requirements are met here, and here we are testing a claim about a standard deviation. And what is the claim? The claim that the standard deviation of waiting time is less than 1.2, less than 1.2. So the claim contains a parameter less than a number. This one must be the alternative hypothesis. So the alternative hypothesis standard deviation is less than 1.2. So it cannot be part A, because the alternative hypothesis is standard deviation is less than 1.2, so that's correct. However, the null hypothesis is wrong. In the null hypothesis, the parameter is always equal to a number. So the right answer must be part B. The standard deviation equal to 1.2, and the standard deviation for the alternative is less than 1.2. So this is part B. This is the right answer. Let's check our answer. Okay, so that's correct. Now we need to find the test statistic. The test statistic for standard deviation is chi-square. Now, we don't have the summary of data, but we have the data itself. So you click on the table here, and you go to the little square here, or little rectangle. You click on it, and you open it in StatCrunch. You wait for it for a few seconds. Might take a little bit here, loading the information. So the waiting time that we just saw is right here in column var1. Okay, and now we need to find the test statistic. So to find the test statistic for standard deviation, you go to stat, you go to variance stats. Variance stats is used for standard deviation or for variance. Since we have one sample, we click on one sample, and we have the actual data. The data is in var1, so you have to select it. So make sure you double click it, and it's right here selected. And since we are dealing with hypothesis testing, that's the one that's selected here. But keep in mind here, what you have is the variance, not the standard deviation. So you have to enter the variance. What we have here, the answer is part B, so we don't need this anymore. The answer is part B. So we have the variance equal not to 1.2. It's not equal to 1.2. It's 1.2 squared. It's 1.44 because the information here is given to you in variance. So it's 1.44. That's your variance. And we're dealing with a left tail test, so it's less than. So the alternative hypothesis would be less than. Okay? You might want to enter the critical value if you like. I'm not going to need it for now, so this is what I'm going to hit compute here. So as you can see, the alternative hypothesis give me the values in terms of the variance, which is 1.44, and here's the p-value, and here is your chi-square stat. So this is my stat right here. I'm going to take 3 digits after the decimal point. I don't think I'm going to need them all. And let me minimize it. And they just need 2 digits, so that I'm going to be 24.44. So this is your test statistic. Check your answer, and here's the answer. So now we need to find the p-value. The p-value, we already found it here. The p-value is less than 0.0001. If it's less than this value, then it must be all zeros. So it must be 0.0000. That would be our p-value. So now they want us to make a decision. So if you notice, the p-value is 0, and this is definitely less than the significance level, which is alpha. And you know that when p-value is less than alpha, you have to reject the null hypothesis. Now, we usually say that first, but in the way they put the question here, you reject the null hypothesis, so the null hypothesis is rejected here on the right side, okay? So the null hypothesis is rejected. What does that mean? If the null hypothesis is rejected, then we have evidence to support the claim. Now remember, the claim is the standard deviation less than 1.2. So we reject the null, we have enough evidence to support the alternative, which is a claim. So you can say that there is enough evidence to support the claim, or to support that the standard deviation has been reduced, or the variation has been reduced. So let's see. There is or is not sufficient evidence to conclude that the single line reduced the variation. Yes, it did reduce the variation. Remember, standard deviation is a variation. So there is sufficient evidence to conclude that the single line reduced variation among waiting time, because the null is rejected. So let's check our answer. And that's our correct answer. And here's an example of how to test a claim